Hello students, welcome to our online study YouTube channel. Now in this video we will study the BET theory. In the previous parts we discussed about Langmuir theory of adsorption, what is adsorption, and then Freundlich adsorption theory. Okay, after that we are going to study BET theory of multilayer adsorption. The Langmuir theory of adsorption is restricted to formation of monomolecular layer of the gas molecules on the solid surface, and this regards the possibility that multilayer adsorption may also take place, and therefore new theory is proposed. The theory of adsorption proposed in 1938. In 1938, the scientist Brunner, Imet, and Taylor. These three scientists proposed a new theory. In this theory, they state that the multilayer adsorption. So, from the initial of these scientists, the theory is known as BET theory. BET theory of multilayer adsorption. Okay, in 1938, Brunner, Imet, and Taylor proposed this theory. They assumes that physical adsorption resulting in the formation of multilayers is the true picture of adsorption. In BET theory, it is assumed that the solid surface, first assumptions, now we are going to discuss some assumptions. The first assumption is the BET theory, it is assumed that the solid surface possesses uniform localized sites, and that adsorption at one site does not affect adsorption at neighboring sites. Does not affect adsorption at neighboring sites. Okay, so first assumption is that the solid surface should be uniform. It must have localized sites, and that adsorption at one site does not affect the adsorption at neighboring site. For example, this is the solid surface. Okay, consider this is the solid surface. Okay, now there are some sites of adsorption. Okay, consider these are the sites of adsorption. So if the gaseous molecules are adsorbed on this surface, then these sites should not be affected by this adsorption. Okay, this is the first assumption. Okay, now the second was the molecules can be adsorbed. The molecules can be adsorbed in second, third, fourth, and so on, and nth layer. Nth layers. The surface available for the nth layer, being equal to the coverage of the n-1th layer. The molecules can be adsorbed in second, third, fourth, and so on to the nth layers. The surface available for the nth layer being equal to the coverage of the n-1th layer. Okay, so means what? If the molecule is adsorbed on first layer, for example, this is the solid surface. Again we are going to draw the solid surface. There are some sides. Okay, on these sides the gas molecules are adsorbed. Consider this is the first layer. Okay, this is first layer, and now some molecules are adsorbed onto the second layer. Okay, this type. Okay, some number of molecules are adsorbed on third layer also, like this. Okay, some molecules are adsorbed on the first layer. So it may continue to the nth layer, and the nth layer have the surface equals to the coverage of the n-1th layer. Okay, that means it requires the for example, here the second layer. Okay, this one is the second layer. This second layer form. Okay, and then the third layer is also formed. In how much surface? It adsorbs only the second layer surface molecule is available. Okay, that means how many molecules are cover the surface of previous layer. On the basis of that, the next layer is formed. For example, here consider this is the second layer. Okay, this is first layer. On first layer, how much surface is available? This one. Okay, and on the surface of this first layer, the second layer is formed. And also again, if you want to adsorb another molecules, then how much surface is available for them? Then this surface is available for third layer. That means here third layer is formed. Similarly, if you want fourth layer, then how much surface is available for them? Then this is the surface is available, and here the fourth layer is formed. That means if you want any layer adsorbed, then it requires the previous layer coverage area. Okay, so this is your second assumption. Now the third assumption is related to energy. The energy of adsorption in the first layer that is E1. Okay, it is denoted by E1, is assumed to be constant. Is assumed to be constant. and the energy of adsorption and the energy of adsorption in succeeding layer is assumed to be same to be the same as the energy of liquefaction of the gas. That is EL. Okay, it is denoted by EL. That means the first layer has the energy is assumed to be constant. Okay, first layer, that means E1. Okay, E1 is assumed to be constant, and the next one, the energy of adsorption in succeeding layers, is assumed to be the same as the energy of liquefaction of the gas. Okay, for example, this is the solid surface. The first layer is adsorbed. This one is the first layer. Okay, and it has the energy E1 is constant. Okay, now the second layer is also adsorbed. Okay, this is the second layer, and it has E1, it has the energy E1. And the third one, and this E2 is equals to the energy of liquefaction. This E2 is equals to, or it assumed to be same as the energy of liquefaction of gas. That means the gas molecules are adsorbed. That means these are converted into liquid. So here we assume that the energy of adsorption in succeeding layers is assumed to be the same as the energy of liquefaction of the gas. Okay, understood these three assumptions? In first assumption we studied that the solid surface should be uniform and it has the localized sites. Okay, and the next is the adsorption at one side does not affect to the second side. Okay, in second assumption we studied that the molecule can be adsorbed in second, third, fourth, fifth, nth number of layers, and the surface is available for the nth layer is being equals to the coverage of the previous layer. Okay, and the third assumption is the energy of adsorption in the first layer is assumed to be constant, and the energy of adsorption in succeeding layers or the next layer is assumed to be equal to the energy of liquefaction of the gas. These are the basic assumptions, easy assumptions. I hope you understood it. Now the next topic is, then these are the assumptions. After this assumption, what we get? The equation. Okay, the Brunner, Emmett and Taylor derived the one equation, and that equation is known as BET equation. Which one is BET equation? BET equation. Which one? This is P upon V total P0 minus P is equals to 1 upon V monolayer into C plus C minus 1 upon V monolayer into C into P upon P0. This is the BET equation, and how this equation is derived we will see in the next part. Okay, if you like this video, understood these assumptions, then give thumbs up and share with your friends, and don't forget to subscribe the channel. Okay, thank you so much for watching this video.